Ladies and gentlemen, welcome to the demo on integrating blockchain in industrial control systems. The industrial sensors and machine processes are connected to PLC directly. The data which is being sent from PLC upwards is not safe and is prone to many attacks. We can add private blockchain between PLC and SCADA. The reason of private blockchain is that it only allows the relevant people to view the data and is not public. The figure shows an animated block diagram for integration of blockchain in industrial control systems. The data which is coming out of the industrial PLC is first rerouted out of the ICS model and feed to the embedded device. There are various types of embedded devices that can be used depending upon the load of data. For the demo purposes, Raspberry Pi 3B Plus was used. As it can be seen, the data first moves out of lower layers to the PLC. This PLC is sending data to Raspberry Pi. The Raspberry Pi is a lightweight blockchain node. The duty of the Raspberry Pi is to receive the data coming from PLC, and reroute this data as transactions to the blockchain. The data from PLC can be written to a text file, which can then be fed to the blockchain. The data from embedded node is added to the transaction pool of the blockchain via new transactions Flask application defined in the blockchain code. It is then up to the main node to add the transactions to the blockchain. For this demo, instead of PLC, scripts were used to get sample data. There have been various attacks been done on PLCs, including Stuxnet attack on Iran nuclear program, Duqu virus, Havex virus, and ransomware attacks. Some of these happen due to lack of security for data. We can use strong but decryptable encryptions to protect data. The data can be encrypted in blockchain layer and decrypted when sending it to upper layers. The main node of the blockchain mines new block. All the transactions are added to block. These are then extracted to send the data upwards. In the private blockchain, hashing can be used to ensure the integrity of the data. Once the data has been downloaded and extracted from the chain, it is then further sorted as per the type of sensor values. The values are then sent to different kind of databases. For the purpose of this demo, the data was stored in an SQL database. The database was then viewed via database viewer. The preceding sections of this demo will visually show the steps that have been described in this demo. The extracted data is then rerouted back to the industrial control system by sending it to SCADA layer. Another reason why private blockchain was preferred for this demo was that it allowed us to store the data directly inside the blocks as transactions. There is an expensive alternative of this blockchain. IBM offers a IoT blockchain which it claims is capable of storing data inside the blocks. But IBM charges a big fee for the blockchain. Blockchain can be used to improve the security of ICS in a number of ways. Overall, blockchain has the potential to significantly improve the security, efficiency, and transparency of ICS. One of the biggest challenges is that ICS are often legacy systems that were not designed to be connected to the internet. As a result, they can be more vulnerable to cyber attacks. So now, ladies and gentlemen, we will begin the demo and show you briefly the different steps of the blockchain for industrial control systems. For the purpose of the demo, showing localhost was used in some parts. For real testing, IP addresses of the systems have been used. Welcome to the demo on the use of blockchain inside industrial control systems. The first step in integrating blockchain is to generate sample data. We needed to generate sample data as PLC was not available for demo. The data is generated by running the Python scripts. The data is then merged into one file, and that file is then sent to the transaction pool for testing. The data is generated using the frequencies, data rates, and other values available for real-time sensors. These values are then added to the scripts. The PLC is going to be connected to Raspberry Pi for the 8 GB version. The PLC is going to feed data to Raspberry Pi 4. For demo purpose, the data is generated on Raspberry Pi. The Raspberry Pi is lightweight node of a private blockchain set up from scratch. We then set up Python virtual environment, which is needed to run the codes without errors. Python version 3.11 is needed. Once the Python virtual environment has been set up, we need to generate the data for the virtual sensors. The data is generated using scripts for virtual sensors written in Python. These scripts are written using values similar to the real sensors. The frequencies for which these scripts were tested are given in detail in the GitHub repository in details. We need virtually generated data as we don't have PLC for demo. The data from all the scripts is combined into a single file to send to the transactions pool. Once the data has been generated successfully and merged on Raspberry Pi node, the data is then sent to the private blockchain. This is done using a Python code. Remember to replace the IP address of the full node blockchain in the code before execution. The sample transactions are then added to the main node's transaction pool. The Raspberry Pi node is a lightweight node, hence, it cannot add the transactions to the block and mine blocks itself. Also replace the text file name and path to file with that of the file containing your generated data or PLC data. The add transaction is performed using a Flask application. Transactions/new Flask app was added to the blockchain code to enable adding of transactions to the transactions pool. The Raspberry Pi is running Ubuntu server, so for demo purposes only the transactions have been shown to be sent from desktop terminal. Once the transactions are in the pool, the mine function can be triggered in order to add transactions to the blocks. Now that all the transactions have been mined and added to the blockchain, it's time for data retrieval. In order to retrieve the data, first start the blockchain. The chain is pulled to make sure that data indeed exists on the chain and was retained even when the node restarts. Remember that you need to add the IP address of the full node to the blockchain code, and also use the updated IP addresses of the nodes when adding them as neighbors and peers. You can also use your own desired port for communication. The following code was written in Python to automate the data retrieval process from blockchain to database. First it retrieves the data and saves it to file. Then it sorts the data into separate text files for each type of virtual sensor. Then the sorted data is sent to the database by this code automatically. Note that your blockchain should be up and running for the code of data retrieval to work. Your IP should be the static IP of your node and chose the port as per your needs. Then add these to the code for data retrieval. In this part of the demo, the data files created by the Python automatic script are visually shown. These files contain the data for individual sensors. This is used to sort the data. In case of this demo, the data was sorted based on sensor names, as name of the virtual sensor was added while generating the data. Our code had converted the data in blocks to files and also sent it to SQL database. Database Viewer was used to visualize the data. The data has been added to separate tables. Logs were generated in blockchain's terminal.